All right, so this is and on this one I'm going to show you the closed captioning feature of Google Slides, but this is the math centers that we did for Tech Tuesday. So we started off with this quote: "Don't limit a child to your own learning, for he was born in another time." And I started off with this quote because this is from a 19th and 20th century poet, so thinking about the 1800s, late 1800s, and early 1900s that this was said. And we have to think about that we were born and we learned and were taught in a different time than our students. And so sometimes our strategies that prepared us might not necessarily prepare our students for their futures. So I think it's important that we are always reflective on that and think about what are the best practices for our students' futures, because they do definitely live in a different time than we did. So we started with understanding the why of why we might want to do centers, and it's important that we always think about why when we implement change. So why would we want to implement it? If we can figure out why we would want to do something, then we can go about understanding the how and how we might implement it more effectively. If we don't know the why, how could we know what to expect as a result? So we don't know what we're looking for if we don't know why we're doing it. So some ways that we can do this is we can differentiate. And when we think about this, there's three different ways we can differentiate. We can differentiate by the product. So what is it that students will do or make to show that they learned something? So if we can give students a choice in what they produce as a result of learning, that can be a method of differentiating. The process: how do students make sense of what they learn? Do we give them time to talk about it, write about it, draw about it, share with others? Do we give them time to think about it, or do we expect an answer right away? And then lastly, the content. So what is it that kids are learning? They don't always need to be on the same content at the same time. We know that kids learn things at different paces, so we might be able to challenge some students to learn something new, but we might have students who need to review a previous task. They need to have some additional practice. Maybe we have some students who they need to be more open-ended and kind of independent in their learning. Next is that when we do centers, we can allow for continued practice, which means that we're developing mastery. So we know that not all kids master a concept at the same time, but centers allow opportunities for students to develop mastery of concepts that they still need to practice. And then this is probably the best one here: small groups. So this is where we can really get effective instruction. We can level our groups so that we are challenging the higher level students, and then we can also support the lower level students, and we can teach the content differently to them. And one thing that I've learned is that if we plan to teach to the middle level, then we're planning to teach to no one, because we really don't have a student who sits at that middle level, especially in all the subject areas. There's so many different types of students out there that we need to really plan on our class instead of just the middle. So thinking about how we implement this, I got this from Mr. Elementary Math. He has a site, mrelementarymath.com, and this is what he recommends thinking about before you go about planning math centers. So first, time and frequency. So thinking about how long are you teaching math for? Think about how much of that time will be dedicated to centers. How often will you do centers? So maybe you'll only do 20 minutes per day. Or maybe you'll just do it one day per week, or one day every other week. So thinking about that time. Then thinking about the routines and procedures. How are students going to transition? What about the conversations that they'll have? What about early finishers, cleaning up? Are they going to be doing partner work or group work or independent work? And thinking about how you're going to group your students. Are they going to be in pairs? Are they going to be in groups? What's the number of size? Are you going to group them by ability level? Student movement. Will they be transitioning from a center, from a place to place, or will they be working at these things in their desks? How will they know the order of the centers? And then if you're moving around classroom space, where will you locate these centers? So thinking about the location and kind of having them separate from another center. What are student needs? What if a student needs something during a center while you're working with another group of students? How do they handle that protocol? If you're using physical materials, where are you going to store them and how will students access them? And then your behavior expectations. How will students know about the expectations of what they're supposed to do at the center? How will you monitor that, and how will you keep them accountable as well? So I'm not going to dive into these tools in this video. I'll have a separate video for each of them. But one of a really cool site, mathlearningcenter.org, they have a section there for resources. There's iPad apps and Chromebook. All of these are available on both platforms. So if you check out an app here and you want it on your iPads, make sure that you let Ben know that you would like to have that installed. So here they are. First, there's an app called Fractions, which allows you to quickly create fraction bars or circles, and you can fill in parts of the whole, you can draw on it, and you can annotate it. So it's a great way to easily divide up fractions and compare fractions and things like that. Next is a geoboard. So, the normal geoboard, you have the little nails that are sticking out and you use rubber bands. This is a virtual geoboard that lets you do the same thing without actually having the physical boards or the bands or anything, so nothing is broken or lost. They can explore geometry and shapes. There are vocabulary cards, and these are broken down into different grade levels and different math terms that would be that students would learn in that grade. So it's just great for practicing and seeing if we can remember these terms or being introduced to a new term. There are money pieces. So if you're learning about money, you can see the money in relation to a grid. So for example, a quarter is shown on top of a 5x5 grid. So as you're dealing with money, you get that other visual of what it represents as well. There are number frames, which I've especially seen this in like kindergarten when you're doing things like making a 10 or doing single digit addition, things like that. You can create a variety of number frames of different sizes and do math that way. There's the number line, so that they have a visual number line. They can draw on it again, annotate, all that stuff. Then there's number pieces, which is like those base 10 blocks that connect together, so they can use that and do that in hundreds, tens, and ones to represent different numbers. Then there is a number rack, which is, I think it starts off with just one string across where you have the 5 white and 5 red, so that students can start thinking in terms of 5, and you can add more lines going across as well if you get into bigger numbers. Then pattern shapes, which are those those blocks of different shapes and colors that you would connect together, kind of like tangrams, I guess. So they can create their own patterns or images, or there's a variety of silhouettes in there that they can fill in and use different shapes to make that. We also talked about some different web tools as well. So the first one that we talked about was quizzes, which is allows you to do multiple choice quizzes with immediate feedback. And if you've used Kahoot, it's kind of like Kahoot in the fact that you can compete against each other, but you don't have to do this live. You could do it as a homework session, and you don't all have to be on the same question at the same time. In fact, when I usually do it with students, some of them are moving along faster. Some of them start with different questions. It kind of randomizes the questions, but it gets them immediate feedback. It's pretty fun. It gives you a whole lot of data to see what students still need to work on. You can give students the option of working on it several times so that they can improve as they're practicing. The other one is just FreeRice, freerice.com, which is it also has some language aspects as well. But you can practice math facts. They end up being multiple choice. So like 3 times 3, they would give you 4 different options. And as you get correct answers, you're actually earning rice for third world countries through the World Hunger Program. The World Hunger Program is donating that. So if you think about that as just some additional practice, you can connect this with other biblical principles in your class as well. Next is Quizlet, which you may have used in other situations as well. It's definitely great for vocabulary, but you could do certain things with math facts as well. I especially think of learning your multiplication facts and being able to visually see what something like 7 times 8 represents, like within an array, so an area grid. Students can practice those facts and match them up with things like that, or with their direct answers. But it's a way to give students a visual. There's different types of games that students could play on that as well. There's also Quizlet Live, which is more of a team-based game where students compete in teams to finish your vocabulary set fastest. Prodigy is another one that I would recommend more for the upper elementary, and this is more of a game-based environment. Students actually go and they create their character and they're going out and completing different quests, and all these quests require them to complete math. You as the teacher get to kind of set the grade level for your students and what standards you're going to cover. And so as students go through those things, they'll be introduced to these math concepts, and as they progress further in the game, they'll be introduced to the more difficult ones. You can also create your own assignment so that you can assign a certain topic, so that when students go in and they're doing their quests or they're battling against other people, they're actually working on math problems that you have assigned, the content that you've assigned, instead of just what they're ready for. Or whatever's next in their game. Next is Khan Academy, which I know several of you use already. There's a variety of exercises and videos, so students are able to get immediate feedback. This is great for centers if you're just kind of individualizing the instruction so that students can work on what they need at the time. You can assign things, or you can just have them work on their mission where they kind of get to choose what they want to learn. This is great for reinforcing concepts that are needed, and you also allow your higher level thinkers to explore new concepts. Then lastly, Math Playground. There's a variety of math games here, some different math tools, like with the Math Center that we looked at on the previous slide, some different word problems that you might use in your class as well. So this is where I think the real beauty comes in, when students are able to explain their thinking. And when we think about explaining, what's nice about this is that the activity itself doesn't have to be done digitally. It could be a physical activity. We can do it with hands-on. But when we give students the opportunity to talk through their math and think through it, they get a better understanding of it. And that also helps us hold them accountable. We could have a student doing a center over yonder and I'm not over there. How will I know that they're actually doing it correctly and that their thinking is correct? Well, if I have a workflow established of how they're going to explain their thinking, and then where that explanation goes, so where they're going to turn it in, I'll be able to kind of see what they're doing, how they're thinking, correct any misconceptions. And what's great about this is that as they're thinking about it, they're probably going to identify some of those mistakes that they've made as well. So when we think about the iPad, there is the built-in screen recorder, which I believe that you will need to go to the settings to first enable this. You'll have to add it to the control center, and then there's an option there that students need to understand on how to turn on voice narration. Another one is EduCreations, and this is on both iPad and Chromebook. So you can add students to your class, and then you as a teacher could use this as a tool to distribute lessons. So you could be drawing out some different things and recording your voice and basically teaching a math lesson that students would have access to. But students can also use it as a digital whiteboard to demonstrate their learning. So maybe you give them a problem and they're writing it out and explaining why they're doing it that way. You might have something physical and they actually take a picture of it, and then they can draw on it and record themselves and submit it to you. So I know many of the iPad teachers use Seesaw. So this is an opportunity for students to share their work, and you as a teacher can distribute different activities. So there's a variety of ways that students can import a picture, they can annotate on it, and they can record their explanations as well. I'll get into Flipgrid a moment later. Screencastify, this is a Chrome extension that is widely used. It allows students to record their screen, and it gives them some different annotation tools so they can set up their problem ahead of time, and as they're explaining it they can draw some different things. They are limited to 10 minutes, but you definitely don't want them going over 10 minutes. The video itself stores in their Google Drive, so they get a folder called Screencastify, and that allows them to add this to Google Classroom if they wanted to turn it in that way. You might also use WeVideo. There's a screen recording feature built in. And it would allow students to have a video without any watermark. They could do it unlimited time. They could also get some different editing features if they needed. I would probably just stick with Screencastify for the basics. So with Flipgrid, this is a great way for students to just respond and explain through video, and it allows students to respond to one another as well. So you might pose a problem and students might respond to that, but then later on they might look at someone else's response and then reply back to think about or to say something about their thoughts. You might also use this to actually app smash, where you use one of the other apps where students have used the screencasting tool, and then they upload that to Flipgrid so that other students can see their explanations, their visual explanations, and then they can respond with their thoughts. So we looked at an example here. We'll pop in. So here's an example that I made on Google Slides right here. So it's just a template. As just the rules that I expect them to do, some directions, follow the instructions. At the end of your last zone, they're going to put this document onto Google Classroom. I might have them add some other things if needed. But, for mine, I've created this just with 5 zones. So you have to think about the number of zones that you would want as well. So I have the first zone, learn something from the teacher, and all the instructions are right here. Now let me go over that. We have instructions, evidence of work, so how are they going to show that they were working here and on task, any additional resources that they would need to access the materials or anything like that, and then what to do when they are finished. So the first one is learn something from the teacher, and for this I wouldn't need any extra evidence of work because I'm there and can observe that, and when they're done, that means we're done with our zone. So this next one is do the quizzes quadrilaterals. Type your points in accuracy. Your goal is to get 70% accuracy or better. So their evidence is right here. I can have them just type that in right here. I give them the link and the code that they would need, and then if they're done, well, they can play it again and try to beat their first score and accuracy. So the nice thing about this is that if students, you might think, well, why wouldn't the student just put down they got more points and like 100% accuracy? Well, by going through this, by having them do this, I get data as a teacher, so I could always double check that as well. And that's probably where I would go if I wanted to see how students did on the quizzes. I probably wouldn't just look at each of their things right here, but I would get better data on my quizzes platform. Next is Khan Academy. So I've just given them instructions. Continue working on your 4th grade mission. Record how many energy points you earned from the activity graph. So they're able to write that down, which would show how many points they earned during that class period or that day. I give them the resources right here, and they're just going to keep working until the center's done. They can't ever actually finish. Another thing is that you might give them a couple assignments that you want them to do that might relate to the topic that you're teaching. This next one, use Google Drawings, Pattern Shapes, which is that app that I was referring to earlier, or your physical pattern shape. So I might have these blocks available as well to create an image. Use only quadrilaterals for this activity. Once finished, take a screencast, or you could take a picture and record if you did it physically. Explain what you made, what shapes you used, and what challenges you had. So now they're talking about, they're identifying the different quadrilaterals that they're using. They're talking about how it may have been difficult to do this, what shapes worked really well together, and thinking about why did those shapes connect, or if I wanted to do something, what shape did I have to use. And then their evidence is going to be their screencast link, so they might just post their link in here to that screencast, or you could have them add it to Google Classroom or Seesaw. So I give them the links right here, and if they're done, they can always make another one. Then this last one is complete the Frere Model Graphic Organizer for types of quadrilaterals. And I give them a resource right here, and if they're done, they can go to freerice.com and continue working on their math facts. So this one, I'll jump into this one just so that you could see this. I've made it so that it will automatically make a copy for them, so they get their own copy. But basically, the Frere model is a great way to kind of organize and think about vocabulary on a deeper sense. So this doesn't have to be done with math. In fact, we actually just did this in our TFT training the other day. So you put the vocabulary word in the middle, and then you have 4 different squares. In this one, we have the definition, some facts or characteristics, some non-examples, and examples. So quadrilateral. The definition that we might put would be like a closed 4-sided shape. Some facts or characteristics, 4 sides, 4 angles, measures 360 degrees, and things like that. Non-examples, we might use some shapes from right here, and we might put in some triangles or a circle or a pentagon or anything like that. We could also use this polyline, and they can kind of click and make their own shapes as well. So they would do non-examples over here, examples over here. So they might, use the rectangle and make a square. They might, parallelogram, trapezoid, different things like that. And then it goes deeper. So what's a parallelogram? So differing that from a quadrilateral, what's a rectangle, and then what is a rhombus. So getting deeper into their vocabulary right there. So I'll demonstrate some of those tools in another video so that you could see them more closely. But when we talked about our ideas, we did some different things. We shared sometimes we might do centers for all of our subject areas where we do math with the teacher, and then they're working on a language activity and then maybe a science activity elsewhere, and so they can kind of rotate through that. And we talked about just the planning for this, that it does take time, and it's probably not going to be something that you do every day. But we need to think about why we might want to do it, and if we want students to really master a concept or to be able to reach those lower level students and help them achieve more, this might be a way to study some concepts and hit them again. So we had some great conversation, great discussion. People were talking about, yes, I want to try some of these things. So if you want to try some of them, if you want me to come into your room, I can kind of help facilitate the tech side of things. We can plan one together and I can do the tech side of things. Or if you want to kind of just be the background observer, if you want me to kind of work on maybe the small group lesson, I could do that. Well, you just get the opportunity to observe how the center is flowing. So just let me know if you want to do it, when you want to do it, and how you want to do it.